Alright, so in this video we go over section 2.4 applications of derivatives to marginal analysis, in which we will calculate marginal cost, marginal revenue, marginal profit, and in the end marginal average cost. Let's start with the very beginning with the basic, which is calculating marginal cost. Marginal cost is defined as the rate of change of the total cost per unit of change in quantity X. And to illustrate this concept, we're going to look at this short example in which we have a specialty item manufacturer that determines that the cost of producing X ballpoint pens is given by the cost function C of X equals 500 plus 3X in dollars. So in this case, the cost is in dollars. Find C of 101 minus C of 100. That is the cost of producing the 101st pen. So in this case, not yet, no calculus involved yet. So, what we're going to do is calculate on the one hand C of 101 and C of 100. For the cost C of 101, well, we're going to do 500 plus 3 times 101. And for C of 100 is 500 plus, and we make this look like a plus, 3 times 100. So in this case, well, so multiplying this, that's a 500 plus 303, which equals 803, and 500 plus 300 which give us 800. So we want to find the difference between these two quantities. So subtract these numbers. That's all we do. Subtract these two numbers to get $3. So the way we interpret this result is that it costs $3. The production level is increased from 100. When the production level is increased from 100 to 101 pence, the total is increased by $3. So the cost of producing the 101st pen is $3. Let's do this same operation using calculus this time. So C prime of X, take the derivative of 500, which is 0, the derivative of 3X, which is just 3. Well, in this case, notice that we get the exact same result as if we did it without any calculus. And the reason for this, well, it shouldn't be surprising that we are working with a linear relationship. And well, when you take the derivative of a linear function, you just get a constant. That is, it's the rise over run. The rate of change is always the same, and this is the situation in this case, right? So that's why we get both results to be the same. So in this case, well, let's look at the next topic, which is marginal revenue, and we define marginal revenue as the rate of change of the total revenue per unit change in sales when the level of sales is X items. Now suppose we have a manufacturer that has determined that the price of certain custom-made tables he produces can be determined by the demand function P of X or D of X. So the demand function is actually the price function as well, and that's 117 minus X over 4. Find the revenue function. Okay, let's find the revenue function. Number 1. Okay, so we find the revenue function first by multiplying X by the price or the demand function. So what we do in this case, XP. So for example, let's say that you are selling sodas for a fundraiser. I don't know. So the revenue will be the number of money that you will that you will make at the end of the fundraising. For example, if you sell the sodas for $2, at the end of the day you manage to sell 40 sodas, well, that's X the number of sodas, and just multiply those two numbers. So that's the revenue. That's not the profit. Profit will come up later. Okay, so we multiply X by the price, but in this case, well, the price is variable, where the demand is variable, so that's 117 minus X over 4. So in this case, well, just distribute the X here, and that will give us 117x minus x squared over 4. All right, and well, that's our revenue function. Now determine the marginal revenue when x equals 16 tables. So what we need to do is to find the derivative of big R, that is the derivative of 117x, which is just 117, and the derivative of negative x squared over 4, which is 2x over 4, which reduces to 117 minus 1/2 x. So that's the derivative. Now what we need to do is to evaluate this derivative at the value where x equals to 16 tables, and then we're going to interpret that value, that result. So 117 minus 1/2 times 16, which is x, right? This is what we're plugging in, evaluate, which is this x. All right, and well, 16 over 2, which is 8. 8 subtract from 117, that's $109. Well, what does that result mean really? So this means that even though the revenue is increasing at a rate of 100, the revenue is increasing at a rate of $109 per table at a moment where the 16th table is sold. All right. Now let's look at the third part, which is marginal profit. Marginal profit, in a very similar way, it's defined as the rate of change of the profit per unit change in sales when X items are produced and sold. All right. So taking the same example as the manufacturer in example 2, the table manufacturer. So this time we are going to consider the cost function to be C of x equals to 25 minus x squared, and the revenue function, which is 117x squared, which is the same revenue function that we found in the previous example. Final break-even points. So how do we find the break-even points? Break-even points are the points where the cost equals the revenue. And we use this piece of information to determine at which point we are at loss or we are making profit. So let's see. What we're going to do is to set these two quantities equal to each other, the revenue and the cost function, and we will solve an equation for the variable x. So let's see. So the cost, which is 225 plus 2x squared equals 117x minus x squared over 4. And well, to solve this equation for x and to make our life easier here, let's get rid of the denominators of the fractions. And well, here is where we distribute 4, distribute. So 225 times 4, in this case, that's going to give us 900. 900 plus 8x squared equals 117x times 4, which is 486. Oh, actually, 468. X minus x squared. Of course, because we have a quadratic equation, you might want to have everything on one side of the equation. We manage that by adding x squared to both sides and subtracting 468 to the x, to both sides actually. Um, so having everything on one side, we get, well, number one, see how these x squareds cancel and 468x cancel. And the only ones terms that get added up are this 8x plus x squared. Let me highlight it with a different colors. Yes, this one makes better contrast. That's going to give us a 9x squared minus 468x plus 900 equals to 0. So in this case, yes, this equation looks like really hard to solve because yes, if you use the diamond method or the guess and check method to factor this polynomial, well, you will have to multiply 9 times 100. That's a big number. Yes, it's doable. However, instead, I would check if all numbers are divisible by the leading coefficient, which in this case is 9. And in this case as well, it happens that they are all divisible by 9. So in this case, well, so x squared minus 52x plus 100 equals to 0. So we can factor this equation. We can solve this equation by factoring rather. And all we need to do is find factors of 100 that add up to negative 52. What are those two numbers? Well, so on the one hand is negative 2 and negative 50. All right, because negative 2 times negative 50, that's 100, and negative 2 minus 50 equals 52, negative 52 rather. That means that using the zero product property, x equals to 2 and x equals to 50. So this is what we have for the break-even point. So the way we are going to interpret this is by locating this these order pairs right here. Those are these break-even points are the 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 points where the cost is equal to the revenue, and these points are going to tell us the limits or the bounds that in which either we make profit or we start losing money. And this is how we are going to interpret later. So let's find the marginal profit when x equals 10 and x equals 30. Number one, we need a profit function. To find the profit function, p of x, what we need to do is to subtract the cost from the revenue, that is revenue minus cost. Because again, taking back the what's gonna happen, the the soda fund, the fundraiser for sodas, so what we do in this case, well, yes, you are gonna make, you're gonna sell 40 sodas at the end of the fundraiser for that day or that week, depending on how often you do this, and or how often you are taking everything into account, and multiply by the corresponding size price. So let's say you sold them for $2 and you've sold 40 of them. Well, you're making $80, right? However, that's not all the money for you, because in this case you need to subtract the amount of money that you invested in cost. So let's say that you bought each soda for $1, you sold it for $2 each. So, well, you need to subtract your cost so you can go and restock again to keep working on the fundraising. So those are two different things. Profit and revenue, that's how they differ. So in this case, okay, let's come up with this function that is 117 x minus x squared over 4 minus the cost function, which in this case is 225 plus 2x squared. All right, So this is the revenue function, and this is the cost function. Okay, and subtracting this, all the ones that we are going to reduce, well, number one, distribute, and the like terms right here are going to be the two squares right here, for which we will have a negative 1/4, that is the coefficient negative 1/4, and minus 2. To combine these two together, be sure to have an LCD. That's going to give us negative 9/4, because 2 times 2 equals to 4, and negative 1 minus 4, 8 minus 8 is going to give us negative 9. So coming up with the actual profit function, P of X equals, okay, let's start with the quadratic terms first. That is a negative 9/4 x squared plus 117x, and then minus 225. All right, so that's our profit function. Now let's find the marginal profit when x equals 10 and when x equals to 30. That is, need to find the derivative of the profit function, and differentiating this, recall that these two goes in the front to multiply the negative 9/4, and getting that reduces to, so 2 times 9 is 18, 18/4, that reduces to 18/9 negative 9/2 of x, the derivative of 117, which is 117x, which is 117, the derivative of negative 225, which is 0. All right. So now let's find the marginal profit when x equals 10 and when x equals 30. So negative 9/2 times 10 minus 117, and well, actually that's a plus, not a minus. Plus, and negative 9/2 times 30 plus 117 times 10, 30, and in each case we are going to get $72 and negative $18. So need to be very, very careful here when interpreting this second result, because the way we're going to interpret this result is that, notice that the derivative, the rate of change of the profit, will actually get smaller as x gets larger, and this is because of this. Look at the variable term. What happens if x gets bigger and bigger? That's going to get multiplied by a negative number, which will become a really big negative number that will be subtracted from a relatively small positive number. So it will get, for that reason, it will get smaller all the time. So in this case, the marginal analysis will show us that the rate of growth of the profit per table, that is actually decreasing at a rate of $18 per table at a moment when 30 tables are manufactured and sold. This is not necessarily meaning that there is a loss, but as the production increases, the profit per table is growing less because costs are increasing faster than the revenue, and eventually you will you will get at a point when you get past the break-even point, you will start getting, or rather losing money, because in this case your cost will be bigger than your revenue. For example, what if for some reason the place where you used to buy the sodas for the what's this called, for the fundraiser, they increased the price I don't know, to $2 now. Well, you buy them for $2, but in this case you still sell them for $2. Well, in this case you're even for now. But what if in addition to that, you don't sell as many sodas as you sold before. That is, you don't or maybe you increase the price by 50 cents just to make some revenue, of course, make some profit. So but in this case, it turns out that because you increase the price, you're not going to sell as many as you sold before. And for this reason, well, so you will have a larger cost minus a smaller revenue. Okay, and one more thing to discuss here in this section is marginal average cost, which in a similar way is the rate of change of the average cost per unit change in production. This is an approximation of the change in average cost when one more item is produced. And well, notice this little bar right here. This bar means average. And let's see what this is about. So suppose the function c of x equals 0.02x squared plus 100x plus 2000 represents the cost in dollars of producing x number of radios. Letter A, find the average cost function. Okay, so the average cost function will be given by the following expression. So average cost function c bar of x will be c of x divided by x. How come do we divide by x? Because we want average cost. It's like when you want to find the average of your 4 exams, what you do is add the score of exam 1 plus exam 2 plus exam 3 plus exam 4 and divide by the total number of exams, which in this case is 4. That's how you find the average. And in this case, well, to find the average of of x radius, well, divide by x, because we don't know what that x is, and it can be anything. It could be 7, it could be 9, it could be 17, 43, 57, 98, I don't know. It could be anything. So that's why we divide by x. So what we do here is, so write down the cost function, which is 0.02 x squared plus 100x plus 2000 divided by x. And well, just divide x squared by x to cancel, get just x. Divide these two x's to cancel them out, and we'll just get 2000 over x as our last term. Let's go ahead and simplify that. X plus 100 plus 2000 over x, and this is our average cost function. Find the average cost of producing 1000 radios. Well, the average cost function getting evaluated at 1000, that's 0.02 evaluated at 1000 plus 100 plus 2000 over 1000. And well, 0.02 times 1000, that's going to give us a 20 plus 100 plus 2, which is the result of dividing 2000 by 1000. So combining these three quantities together, we should get 122, which is the average cost of producing x equals 1000 radios. Now, what is the marginal average cost? So in average, its marginal cost will be, well, find the derivative. But before finding the derivative, which will be from here, which will be from this function right here, you may not want to differentiate just from here, because look at the x in the denominator. That needs to be in the numerator in order to be able to differentiate that. So 0.02x plus 100 plus 2000 x to the negative 1 and c prime of x. Yeah, I forgot to put the x here. It's fine anyway. That's 0.02 plus the derivative of 100, which is 0 plus rather negative minus 2000 x to the negative 2. Where does the negative sign come from? Well, negative 1 multiplied by the coefficient in front of x, that's going to give us that negative. And well, let's clean up this expression. Why not? Because you may not want to work with, negative exponents and clear that 0 there. C prime of x will be 0.02 minus 2000 over x squared, which reduces to, well, it's actually reduced. Now let's plug in for x equals quantity squared, in this case 1000. Alright, so simplifying this to lowest terms, well, so we are going to have this 0.02. 0.02, this is supposed to be a 2. Okay, let me make it look nicer. 0.02, and then minus 2000 over 1000 squared, which will be a big number, which reduces to 0.002, and this will be 0.018 dollars. All right, in other words, you might want to have a an easier number to interpret. This is the same as saying 1.8 cents. And the way we interpret this is that the average cost per radio is increasing at a rate of 1.8 cents per radio when 1,000 radios are produced. And this is the last topic for this section. I think this is a good place to quit. I'll see you in the next video.